All right, we're now in Unit 5, Radical Functions, 10.1. Inverses of simple quadratic and cubic functions. This is day 1. Today we're going to focus on the quadratics, and tomorrow for day 2 we'll focus on the cubics. Remember, to find an inverse, you switch your x and y values. So we're going to kind of do a little recap memory to find the inverse function of f of x. And remember, our notation is f to -1 of x. So if this is our function f of x, and those are all our values, we want to find the inverse. So to do that, we take our x and y values and we're going to flop them. So that would give me 9, -3, 6, -2, 0 would be 0, 6, 2, and then 9, 3. So when we look at this, it asks the question, is the inverse a function? We know that this is a function because they told us. But the inverse, is it still a function? Well, the answer is no, it's not. And why is it not? It's not a function. Well, because I have 9 going to 3 and -3. So each x value doesn't go to its own unique y value. There's a repeat on the x's here. So 6 goes from -2 to +2. So that leads us to the question, can we restrict the domain of this one so that the inverse is a function? Well, if I say that the x values can only be greater than 0, so I'm looking at the original function, then I wouldn't have a repeat because these would not happen, and so therefore they wouldn't repeat on the x's. So yes, we can, and the restriction would be x such that x is greater than or equal to 0. And as long as our x values on the original function are above 0, we wouldn't get a repeat on the inverse. So restricting the domain is how we go about making sure that our inverses are functions. We restrict the domain on the original function to make sure that the inverse is a function. All right, so now let's talk about inverses of quadratic functions. So we're going to look at the inverses of quadratic functions. Inverse of a quadratic function is a square root. Square root and quadratics are the inverse of each other. G of x equals the square root of x is a function for the x values greater than or equal to 0. And that's because we can't take the square root of a negative and end up with a real number. We end up with an imaginary. So whatever we do, our restriction on our domains needs to be that that radical needs to have a positive value. So our directions say restrict the domain of each quadratic and find its inverse. Confirm the inverse relationship using composition. Graph the function of its inverse. So whenever we're restricting the domain, we want to make sure that whatever we do, it's going to be a positive value. It's going to be greater than 0. So since this is being multiplied, as long as the x value is greater than 0, we're okay. So I like to restrict the domain at the end and find the inverse first. And I'll show you why in just a second. But, so to find the inverse, we're going to write this as 0.5x squared. And then I'm going to flip my x and y. And now I'm actually going to solve this for y. But here's the other thing. I don't like dealing with fractions or decimals and dividing by decimals. I think it's easier when you divide by fractions. I'm going to change that 0.5 to 1/2. I need to get the x squared by itself, so to do so I'm going to multiply both sides by 2. I get 2x equals y squared, and then I'm going to square root both sides to get rid of the y. So I get the square root of 2x equals y. Now remember, this is the inverse, okay? So I want to rewrite this in proper notation, because I was given to it as f of x, so I want to write it in the same format. Now, I want to write the restriction. Here's an easy way to find the restricted domain. I simply take whatever's in that radical, and it has to be greater than or equal to 0. So if I divide by 2, that still means x has to be greater than or equal to 0. So here's my restricted domain, x such that x is greater than or equal to 0. You can do it with the dots or with the bar. They both mean the same thing. So this is my inverse, this is my restriction. Now it says to confirm the inverse using composition. That means I'm going to plug one into the other. So I'm going to go right here and say, okay, that means that f of x equals this. And I want to make sure, because here I have whole numbers and decimals, and that's fine. This says that 0.5 times 2, the square root of 2x squared. Okay, so if I square 2x squared, remember, it's a square root of it, so it's 0.5. It just, the square root and the squaring cancel each other. So half of 2 is just 1, and that becomes 1x, which means they are inverses of each other. And the composition worked. It says graph the function and its inverse. So the function, because we restricted the domain, when you go to graph this, you're only graphing one arm. So it is a parabola, and because we want the positive side where it's greater than 0, if I plug 1 in, when x is 1, this is at 1/2. When that's 2, that would be 2 squared is 4, half of 4 is 2. So I'm getting this parabola that looks like this. This is the f of x function, because that's where x is greater than 0. You do not want the other side, or what's called the other arm, because you want only the positive. To graph the radical, if I plug in 0, the square root of 0 is 0. If I plug in, and this is where you want to be careful, because if I plug 1 in for x, the square root of 2 is like 1.7. That's not very fun. But if I plug in 2, 2 times 2 is 4. The square root of 4 is 2, so 2 and 2. If I plug in, let's see, 8, I would get 16. Well, that 8 is going to be, square root of 16 is 4, so it's kind of looking like this. And remember, if you fold them over, they should be kind of mirror images of each other. And that's what we've got going on. So we have our restricted domain. We have our inverse. We did the composition to show that they're equal. And then we graphed both functions. So now let's look at this one. It's a little bit more unique to it, because it's x squared x squared minus 7. We're going to first find that inverse. So let's look at finding the inverse, which means I'm going to rewrite this as y equals x squared minus 7. And then I'm going to switch my x and y. So that's x equals y squared minus 7. And I'm going to solve for x. Or solve for y. We don't want x to have all the fun. And then square root both sides to get rid of the squaring. So I get the square root of x plus 7 equals y. Now remember, this is the inverse, and I'm going to put it back in the format it gave it to me in. Now remember, that radical has to be greater than 0. So I think the easiest way to restrict my domain is to say, all right, I know that it has to be greater than or equal to 0. So when I solve this for x, I get x is greater than or equal to -7. And this becomes my restriction. This is my restricted domain. Right there. I think it's the easiest way to find that restricted domain. Now, we need to use composition, so I'm going to create a little bit of extra space here to find and make sure they really are inverses of each other before we start graphing. So I'm going to take this, I'm going to plug it in there, so I get the square root of x plus 7 squared minus 7. Well, the square root and the squaring, they cancel, so that's just an x plus 7 minus 7 leaves me with x. The composition works. That means they are inverses. Now, graphing these. Graphing can be a little bit of a challenge. The radical, if you remember your shifts in your translations, great. If you don't, oh well. If I plug in 0 for x here, 0 squared, that's 0, minus 7 would put me down here. And remember, it's a parabola, and I only want the positive arm, or excuse me, I want the arm that's bigger than negative 7. And so we're going to go, if I plug in 1 squared, that would be negative 6. So if I kind of just make it 2 squared would be 4, that'd be negative 3. So I'm kind of getting an arm going up like this. This is for my f of x. And to do my inverse, I can put in negative 7. At negative 7, it would be 0. At negative 6 plus 7 is 1. The square root of 1 is 1, so I'd be here. If I plugged in 2, negative 2 would be 5. I want to take the square root of 5. If I plug in negative 3, that would be 4. So negative 3 would be the square root of 4, which is 2. And I get an idea of what my graph is looking like. And it's going like this. And they are mirror images of each other. So this pink one this time is my inverse. We'll practice more in class. I'll give you another example tomorrow. We'll talk about these. But this is the process in which we want to do the problems. So our last one, of course, is a word problem because, you know, we just need to have more practice with them. We try to avoid them. I'm trying to move things around so you guys can get a better look at this. Now, take a minute, write the word problem into your notes. And we have the function d of t equals 16t squared gives a distance, d in feet, and then an object falls in t seconds. Write the inverse function to find the time t in seconds it takes for an object to fall the distance of d feet. So we're finding the inverse. Remember, we're using d and t. So d of t equals 16t squared. Well, that's just saying that the distance equals 16t squared. So we want to rewrite this and switch the t and the d. So I get 16d squared, and I'm going to solve it for d. So I divide by the 16. So that's t divided by 16 equals d squared. And then square root both sides. So now I have 6. I could write what I was saying. T divided by 16 and the square root equals d. Now, remember, this is the inverse. Okay? So this is now the distance that it's falling. So this is the inverse. So we're not using the time divided by there. We're going to use the distance. So d over the square root of 16 equals t of d. In reality, we could have just used this and solved for t and put that in terms. It works. To find the distance of 48 feet, we're going to plug in the 48 divided by the 16 and square root that. That's going to give us the time that it takes. The t in terms of the d. So 48 divided by 16 is 3. The square root of 3 is what we're looking for. Square root of 3 is about 1.7 seconds to fall 48 feet. And there you have it. We'll practice some more word problems. The word problems can be a little tricky. Our restricted domain is that we'd have to be above 0 because we don't want our radical to be